everyone. I wanted to go over the Chapter 6 quiz with you so that you have this to study for your test next Tuesday. A survey is conducted asking random American families how many cars they have. The results are compiled in the table. So Part A is asking us to construct a discrete probability distribution from the data. In order to do that, we're going to have to convert the frequencies into relative frequencies by dividing by the total. So first let's get the total by adding up these frequencies here. If you add these up in your calculator, you get 100. So now to fill in this table over here, to find the probabilities, we'll take the frequencies and divide by the total, and that will be our approximations for probabilities. So the probability that a random American family has 0 cars would be 7 divided by 100, which is 0.07. The probability that a random American family has 1 car is 25 divided by 100, which is 0.25. The probability that a random American family has 2 cars would be 56 divided by 100, 0.56. The probability that a random American family has 3 cars is 10 divided by 100, which is 0.1. And the probability that a random American family has 4 cars would be 2 divided by 100, which is 0.02. Okay, Part B, compute the mean and interpret it as the expected value. There are a couple of ways to do this. I think the easiest way is to take your data values, your numbers of cars, and put those into L1, and then take your probabilities and type those in L2. Then we can use one variable stats to go ahead and find the mean, x bar. Let's go ahead and type these numbers of cars into L1. So 0, 1, 2, 3, 4. And then in list 2, put the probabilities, 0.07, 0.25, 0.56, 0.1, and 0.02. So now that we have our numbers of cars in list 1 and our probabilities in list 2, we're going to go to Stat Calc number 1. Make sure you reference list 1 and list 2. For most of us, we'll have to put L1, L2. For some of you, it'll be list L1, frequency list L2. And then go ahead and get the mean. The mean will be displayed as x bar on your calculator, but for a discrete probability distribution, we'll call it mu. And it looks like it's 1.75. So this is the expected value. I know that it is not a whole number, but remember that it is the average in the long run. So we could say something like the average American family has 1.75 cars. I know that there isn't such thing as a 0.75 car, but remember that's how expected value works. It's an average. So the average American family has about 1.75 cars. Okay, Part C. What is the probability that a randomly selected American family has more than 2 cars? So more than 2 cars would mean they have 3 or they have 4 cars. So those are disjoint, so we can go ahead and just add the probabilities together. So the probability they have 3 cars is 0.1. The probability they have 4 cars is 0.02. So the probability that they have more than 2 cars would be 0.12. All right, let's take a look at number 2. According to a study conducted by CESI Debt Solutions, 80% of married people hide purchases from their spouses. In a random sample of 20 married people, find, and it's saying round to 4 decimal places. Before we start, just note that this is a binomial problem. They've given us the probability of success right here, 80%, so we'll say P equals 0.8. Okay, so in this case, success is the person saying they hide purchases. Looks like it's pretty common. And then the number of trials is right here, 20. So they're collecting a random sample of 20 married people, and we're going to be asked to find a couple different probabilities associated with this. So Part A is the probability that exactly 15 hide purchases from their spouses. So this is the probability that there are exactly 15 successes. That corresponds to when we use the function binom PDF on our calculator. So we'll do a binom PDF. The first thing you type in is n, number of trials, which is 20. Then P, probability of success, 0.8. And then X, the number of successes you're interested in. So we go to our second VARS menu. That's our distributions menu. And you scroll all the way down to letter A, Binom PDF. You either type these in separated by commas, or some of your calculators will actually say trials, P and X for you. Okay, so I did a Binom PDF. To get the probability, I'm getting about 0.1746. I'm rounding it up because the next digit's a 5. Okay, let's take a look at part B. The probability that at least 19 hide purchases from their spouses. At least 19. So that means that there are 19 or more successes. I want to use Binom CDF, but remember that Binom CDF only works for the less than or equal to inequality. So we'll have to convert this using the complement rule. So the complement of 19 or more would be 18 or fewer. So now I can write this inequality with a less than or equal to sign, which corresponds exactly to my Binom CDF function. Remember that the C stands for cumulative, so up to 18 successes. And you can type this in your calculator all in one line. So 1 minus Binom CDF, number of trials, probability of success, and up to 18 successes. So type this all in one line on your calculator. So start by typing 1 minus, then go to your second VARS menu to find your Binom CDF, and then type in number of trials, 20, probability of success, 0.8, number of successes, 18. Okay, so I'm getting about 0.0692. I'm rounding it up because there's a 7 as the next digit. Okay, next one, the probability that fewer than 19 hide purchases from their spouses. Fewer than 19. That would be up to 18. So the probability that X is less than or equal to 18. Luckily, this inequality corresponds exactly to our Binom CDF. So we're going to use a Binom CDF. N and P will not change from problem to problem. The only thing that will change is your X value. Okay, so let's type this in the calculator. So I'm getting about 0.9308. Okay, one more probability here. The probability that between 15 and 17 inclusive hide purchases from their spouses. So let's write this in math notation. We're including 15 and 17. So we put the less than or equal to symbol to show that it could be equal to. There are two ways to do this. You could do individual Binom PDFs for 15 successes, 16 successes, and 17 successes. I'm going to show you a different way in case you ever have to do one where the range of values is a lot larger. That might not be practical. What you can do is you can find the probability for all the way up to 17 successes. So this would be 0 or 1 or 2 or 3, all the way up to 17 successes. That would be one Binom CDF. And then subtract what you don't want. And what we don't want is up to 14. Remember, we only want to find the probability that there are 15 or 16 or 17 successes. So we're finding the probability all the way up to 17 and then subtracting the probability all the way up to 14 to get what we want. And you can type this in your calculator all in one line. You can type in Binom CDF 20, 0.8, 17, close it off, then subtract. And I recommend doing it all in one line because I don't want you to end up rounding more than once in a problem, because then your answer becomes less accurate. Okay, so I'm going to type this all in one line on my Binom CDF. 20, 0.8, 17, and then minus, and then another Binom CDF. Oops, where is it? All the way down here. B. Okay. 20, 0.8, 14. Okay, so I'm getting about 0.5981. Okay, one more part here. It's not a probability. It just says the expected number that hide purchases from their spouses. So remember that in this chapter, expected value has been the same thing as the mean. And for a binomial experiment, the mean is just the number of trials times the probability of success. So that would be 20 times 0.8, which is 16. And what this means is, if you had a random sample of 20 married people, you would expect 16 of them to hide purchase from their spouses. That may or may not happen, but that is the expected value. All right, I hope that helps.